Okay, so welcome to the video game stream where I develop a video game without AI because we killed all the scientists, and we're very sorry about it. But we still have to make video games. So here I am, doing the Lord's work. Okay, so this is done. Today, let's see where we left it off. Let's see, where I left it off was I had a camera that's really just kind of moving up and down a little bit like crazy, but maybe you can't tell. And I've got a yo-yo that moves around and drifts a little bit like they do in Rocket Soccer Cars. I can't remember the name of it, or the name of the game right now, but I stole some drift movement from that game. So one thing I'd like to work on today is, well, first I need to make sure my developer panel can come up, because when I click on this right now, I should be able to see like all the physics, position, and things like that. I need to make sure that's coming up. Second thing I'd like to work on is I want it to look a lot better whenever the yo-yo bounces off of something, because right now it just doesn't doesn't physically make sense. So what I want to see is maybe just some kind of reaction from this thing that makes some physical sense. It can be cartoonish. I think the normal way of dealing with a situation like this would be to make use a very complicated physics engine to solve a realistic looking answer for you. But I'm not really interested in going that route because I know the sort of pain that comes from trying to use a very realistic physics engine to do something very aesthetically specific. And it just seems unnecessary when you could just make it do the specific thing instead. So I'm keeping the physics simple, and then I'm going to just try to make these collisions not look as bad as they do right now, because this doesn't make sense, but it will make sense. It will make sense. It'll make some kind of visual sense, right? Okay, so first thing is I need to get the dev GUI back showing, but I don't want it to take up as much space as it was. The first thing is probably just, I'm going to bring down the font size in the renderer of the dev GUI just a little bit. That's in the, the renderer of the engine. The front end dev GUI we have right here, just a little hard-coded value. I'm going to bring it down just a little bit so it doesn't take up too much space. And then I need to actually make sure the dev GUI actually shows, right? Okay. Oh wait, I should probably make this more readable. Okay. So, if we go into the dev GUI here, I think I just have it. Yeah, I do. I just have it commented out. See how that looks. Okay, so it's taking up, this is the main thing I don't like, is that it's just taking most of the screen, but obviously I can do this, and maybe that's good enough. I don't know. This is okay. Yeah. So I select this guy, I can see all this stuff about it, and that is all I wanted, really. After that, yeah, so I want the physics of the yo-yo bouncing off of things to look like not like what it is. So maybe the best way to do that would be to just get it to stop moving, and then from there generate variations of what it should look like. Because getting it to move, or I could maybe get it to move the way it is and like rotate in order to align with the movement, but I don't think that is the way to go. Let me see if that makes sense. Probably not. So yeah, that, I just don't think that movement makes a lot of physical sense, but maybe if it like rotated, possibly. I don't even know that it needs to make physical sense, it just needs to make like gameplay sense, and I'm definitely not feeling that right now. So like whenever I hit it from this angle, I expect it to maybe, what would I expect it to do? Probably it would, the side that it gets hit on, it would probably turn inward toward that side. So it would spin, and as it's spinning, it would be like sort of moving backwards, I want to say. I also think this sort of thing is maybe one of the hardest parts of game development, is just this completely open-ended situation where it could go kind of any direction, and most directions are bad. This is the hardest part. And, yeah. Also, streaming is not really set up for this kind of stage of development either, right? This is supposed to be sort of a deep moment where I like take out my notepad and start scribbling on it to imagine what it would look like. Or I guess I could take out paint and use that. I could try that. I'll do the streamer version of this. Okay. So, let's say I have a wall here, and I have, oh, this needs to be bigger. Bigger canvas. Wall that has some color, so you can, some solid color, so you can tell it's a wall. Alright. So this is a wall. And then I'll be right back in just 1 second, actually. Okay, I feel like my awesome BRB scroll. Made it a couple days ago, it just runs in the terminal. Okay, so what I was doing was I have a yo-yo, so I'm viewing a yo-yo from overhead, which I guess looks kind of like this, right? This. Oh, that is ugly. Okay, so it's kind of like this. It's moving in this direction, and it makes contact with the wall like this. Okay. Makes contact with the wall. Now, at this point, what I want to say happens is something like this. It starts rotating in this direction because it made contact right here on this fulcrum. It's got this movement, right? It's going to want to rotate this direction and sort of end up, redraw it over here, end up maybe oriented just like straight in the direction of the wall. But it's still going to have some angular momentum, right? When it gets to this point. And then it's also going to hit. So the contact points are, we're moving this direction, and we have a contact point right here on this side of the yo-yo, which is going to give it some angular, it's going to impart some angular, it's going to move some of its linear momentum into angular momentum. So now at this point, this is stage 1, this is stage 2. At this point it's got some angular momentum, and then it makes another contact right here. And I've got to BRB one more time. All right, never mind. So again, it's traveling this direction, hits the wall, contacts the point, the sort of the left yo-yo wheel right here. So it starts rotating this direction, turning some of its linear momentum into angular momentum. At this point, it has angular momentum, so it has rotated, and it makes contact with the other side right here. At which point it's going to want to both continue probably moving this direction, but it's going to lose some of that angular momentum and want to start moving this direction probably because it's hitting a wall and wanting to sort of bounce off of it this way. So it's doing two things, right? It's wanting to sort of continue spinning. So over to the third state here. Third state, after hitting the wall. I'm not sure what it looks like exactly yet, but let's say this is, I'll redraw the movement vectors here so that they're a little more obvious. Going from linear to angular momentum once we make contact with the wall, keeping that angular momentum here and then making another contact with the wall. And then in the third part, I'm not sure what exactly it looks like, but it should continue having some angular momentum, and it should also bounce off the wall, right? So it's going to continue turning a little bit, but some of the angular momentum is going to be converted back into linear momentum and it bouncing off of the wall in this direction, moving backwards, right? So this is, I want to say, if I'm doing this more, if I'm not making it like a really complicated physics system where it more generally solves problems like this, I am at least thinking about how it solves complicated problems for the player character in multiple situations here, because this isn't a situation where like they hit the wall and I can just do 1, 2, 3, where it's going to play out the same way every time. I have to think of these as separate situations where a contact here does introduce, like it does convert some linear momentum into angular momentum. So this is viewed in isolation from this situation where it has some angular momentum. Already it makes this contact, and because it's making contact in on both points, it wants to go this direction. The collider for the yo-yo in this perspective is actually a circle. So what I'm probably going to need to do is actually simulate, because I don't really want to do the multiple collider thing. I'm going to simulate being able to contact the yo-yo at any point by asking, okay, the yo-yo has a circle collider from this perspective. Where did it get contacted along the circle? If it got contacted right here, then that means it got contacted on this side of the yo-yo, right? So I can sort of average out that way, this way. So also here, like if the contact is here, the contact with the wall is somewhere like very much in front, then we can say probably that it contacted both like front edges of the wheel of the yo-yo. So it's very like estimating what part of the yo-yo is hit based on where on the collider that it happened. I might also want to I probably actually want to add a different collider that's a little bit better for this. It looks something like this actually. You have your guy, your yo-yo from overhead. The collider, instead of just being a circle, could instead be something like this, where you have a circle here and a circle here, and if you want to get really fancy, you could connect the circles with a box like this. So you have two circle colliders, essentially two circle colliders, and a box collider like this. And that does is it gives you good side hits as well as good coverage on the front of something that's like not meant to be perfectly box-like. I could actually just use a box collider for this, and that would actually fit it kind of better. But for this use case, I think it would make more sense to have a rounded collider on front, because I don't know, it doesn't really matter that much either way. But for one, this kind of collider is much easier to do collisions with than a box collider. Box colliders on their own are very complicated, but if you just have the box collider handle like side collisions, so there's like box collider, there's circle collider, if we're talking 2D stuff, right? Box collider on its own is like very, very complicated. This is like, super complicated. Circle collider on itself is like, by itself is really, really simple. If you mix the two, like this, and you only use the box collider for side collisions, and then you use the circle colliders for everything else, this is like somewhere in between. It's like 3 out of 5 complexities or whatever, right? So I'll probably go with this one just on that alone. Yeah. So I think I'll start with that. I'll start implementing this sort of like combined box cylinder or box circle collider. And then from there, I can start implementing a physics system that's like catered specifically toward providing information for like deciding how to have these situations resolve in a somewhat physically accurate way, but then also be very controls first and make sure that like the physical accuracy isn't the foremost thing, right? Physical accuracy is a solution you have that you can work toward. But I need to be able to override that for aesthetics and for controls, right? And so it's very controls first, let's say aesthetics second, and physics last, which is why I don't want the general solution. Okay. So, at least now I have a really clear goal here. I can just say, well, right now I'd like to implement this, this collider, right? This. Oh wait, it's off screen. Oops. My bad. So, this circle box collider with a bunch of arrows sticking into it, just meant to show like collision directions, basically. Okay, so that's what I'm doing right now. And that will help inform the collisions later. Let's see. All right. So it's in physics types. You need to add a new shape. The new shape, I could call. Yeah, I've called it a few different things before. But maybe just circle box collider. I'm not really sure what to call this thing. Let's see. The first collision shape is a cylinder. I could call this a pillbox. I think that's kind of that's a reasonable one. I'll call it a pillbox. Pillbox. Even though, what is it? Wait, what does a pillbox look like in real? I know it's like a. Let's see. Pillbox. You know what? Pillbox. It's a pillbox. I don't really care. All right. So a pillbox has. Let's see where it is. Shape pillbox. Let's make it one word. Pillbox. Shape pillbox. Pillbox has. Well, let's look at the diagram. Oh, this is terrible. Jeez. Okay. All right. So a pillbox collider, in order to describe it, has, let's look at what it looks like here. It's got a box and two circles. So this has a, let's say, a height, a width, and a radius. Though if you look closely, if I draw the radius at the same angle, you can see that the radius and the width are the same thing. So it looks like looking at half height and radius, let's say. So this is the half height, this is the radius. I think that's all you need to describe this. I'm not saying, well, plus height in the z dimension, like the height dimension, right? Okay. So we're going to say height is like how actually tall it is, because it's a 3D game. That needs to be in the first position, and then the let's say half length, and then lastly the radius. Right. Okay. So we've got a new shape, and the player character should have this shape. So I'm going to move over to physics properties. The player character riding the yo-yo should have the shape. Pillbox. The height 0.5 is fine. the radius 0.15, I don't care, and the half length equals, I don't know, 0.2 or something. I'll see how these shake out later on. Actually, probably I want to draw them first, right? I want to see what it looks like before I do anything else. So, where am I drawing a cylinder? I think I'm doing draw cylinder in the renderer. So let's see here. Draw interface, draw cylinder. Okay, I also need draw box, which is not super hard, but let's go ahead and make that, right? So draw box. Need to know. You can always have the render. Center is good. We need a, let's say, half width, half length, if you spell things right, and a half height. Okay. And then, so that's if you use an engine like Unity or Unreal Engine, you probably pass that as like a vector 3, like an extent. I'll just pass it as 3 different things. This is fine. Okay. I mean, it's also more clear this way. Well, actually, no. Is it more clear? I don't know. It's fine. All right. So, and then I also need to know. I changed my mind. I'm sorry. It's got to be an extent. Extent is a vector 3, and then the axes also need to be passed. So I need to know what up is, I need to know what right is, and let's say forward. And just like this stuff, I also need to know the color, the line width, segment. No, I don't need the segment count. Whether we draw in front, and how long it's going to be drawn. Segment count. No, segment count is the same for every box. It's 1, 2, 3, 4. Is that 12 segments? 12 segments. It's 12 edges, right? I think I'm right on that. Okay. So, to draw a box, we're going to just sort of move. We can move forward, half step, left, half step, up, half step, and that's one vertex, right? So we just need to draw each edge. And so it maybe helps to define the top center. So the top center is just the center plus the up vector times extent dot z, and then the bot center is just the center minus up times extent dot z. So we're moving from the center of the box that we want to draw, moving up the top center plane, and then down to the bottom center plane, where all of the vertices are, right? Okay. So from the top center, I'm going to add the extent y is forward times the forward direction, right? So the extent y is how far forward we want to move, and forward is the direction of forward, wherever that is, right? So top center plus forward times extent dot y, and then I'm going to say minus right times extent dot x. Extent dot x is like how much width, or it's the half width of the rectangle, the box we're drawing, right? So this is top A. Doesn't really need to be, you don't have to have great names for things like this, I think. Top B. We're going to do the same thing, add forward. So we're going to go forward, but then we're going to go to the right instead of the left. And then for top C and D, we're going to go backward. So forward to left, forward to the right, and then backward to the left, backward to the right. So we have all of our points on the top, right? And then do the exact same thing to the bottom. Okay, cool. So we got a bunch of points. Now we just need to draw lines between them. Okay, that's the easy part. So I'm just going to copy this one from down here. It'll let me. Perfect. Okay. So we're going to draw from top A, top B, and then from top B to top C, from top C to top... Wait, well, let me think about this. B is... See, I don't want to draw across the top, right? So top B is forward to the right. I want to draw from top B to top D. And then from top D to top C. And then from top C to top A. Okay. So it'll be all of the edges of the box on the top side. And then I just want to draw the edges of the box on the bottom side, which all you gotta do for that is switch out top for block here. We'll do the same exact thing. And then I just need to connect them. I need to connect from top to bottom, which is maybe the easiest part. You don't even have to think about anything. It's just top A to bottom A. And then so on, A, B, C, D. Okay, and that is how you draw a box with lines. Easy math. Alright, and so let's see what that looks like. If we go back to physics, I think, let's see, draw colliders, case pillbox. We're just gonna draw the box for now. Okay. Box, and position plus half height. That is still the same center of the box. Okay, let's split this for a second. Just want to see real quick. Okay, so these are the dimensions we're working with. We have, let's see, height, half length. So half length is going to be the step, like the length direction forward, and the radius is going to be the width direction. Okay, GUI, yeah, draw interface. Okay, so we got draw box here. We're going to draw at the center with the extent being, let's see, so again, the width is the radius, half width is the radius rather. The half have length. So this is collider. Let's see, we draw colliders, blah, blah, blah. Let's just say collider is body.collider. Or maybe, let's do that. Cylinder is equal to body collider.cylinder. It's a little bit better. And pillbox, body.collider.pillbox. Okay. So that way, just a little bit less texture. Okay, so pillbox.radius and pillbox at half length. I think, yeah, right there. And then the extent is just going to be the half height. Or the height extent is going to be the half height. Okay, and then up is always z equals 1. I do need the forward and right vector. So forward here, forward vector is going to be get forward, or get forward direction. of entity orientation. Okay. And then the right back we can get with the cross product. So one neat math trick here is if you know where's forward, where's up, you can take a mathematical cross product, and that gets you the right or the left. Okay. So right hand rule is forward plus up is left. I know it's can't really see the camera, so up plus forward or up cross forward is right. So right back is cross, or let's say normalize cross z equals 1 is the height, and then forward back. And I'll get us right back. Oh wait, it's up, right, forward. Okay. And then the color, same color. And same line width. Draw in front, false, time. No, yeah, I don't need to draw in front, and I want it to draw over the course of one front. So, see how that looks. Let's see. String insert. Oh, I'm having a hard time reading this. Half length is not a member shaped cylinder. That is true, because it shouldn't be a cylinder. Where are we? Oh. No problem. No problem at all. Pillbox is not a reference collider. Well, it should be. Okay. Now it is. Now what? Undeclared if I remember, that's fair. That's just me. Okay. Forgot to rename these. There we go. Let's see what that looks like. Okay, so that is a box. Exactly what I wanted. Blue box. Alright, so it's definitely way too tall. One thing I need to work on is like deriving the height of a collider from one of the meshes. I think that would be, it's not like a super hard thing to do. I just don't, I don't want to do it right now. So height is too tall, but it's fine. And if I, I have to get out of this mode. If I turn, box turns with the guy. So now I've got box. This is what, yeah, it's definitely too long. That is fine. Okay. Maybe I should do both box and like pillbox. Liners, I don't know. What should I do? Should I do both? I'll start with this one and then see how I feel. Okay, so Pillbox Collider also draws cylinders. So I'm going make it do that. So we draw a box, and then we draw 2 cylinders, right? Because that's what a pillbox is in this lingo. So I'm going to draw a cylinder. Not there. It's going to be, so let's say, make note of where center is. And then we want to move forward along center by half the length, or yeah, by half the length of the box. So center plus 4 back times the box half length. And that's where the center of the cylinder is. And then we have cylinder radius. What is that for? Draw interface. So center and then radius. Okay. So pillbox radius. And then after radius we have the height, which is going to be half height times 2, right? And I just need to know what the up direction and the right direction are, which I already have, thankfully. So up is always z equals 1, and then right is already gotten. Do I want anything else? Yes, so 2 color 4B. Really need to make this part easier. Color 4F. Blue. Line width equals 2. Okay, so that would be the front cylinder, and the back cylinder would just be the same thing, but center minus the 4 back times the half length, right? Okay. Okay. And too many commas. What's new? So radius. Did I cut that out? I did. Oops. Okay, so center goes there. 2 color B. That's not what that's called. Color 4B for 4 bytes. Okay. There we go. And that is what it's supposed to look like. It's way too long. That is what this kind of collider looks like. It's a box and 2 cylinders. So no problem. Drawing it just fine. Let's go ahead and hack this collider into shape. Let's see. Okay. I guess I just said in physics properties. Height. I guess I do store that. Oh, wait a second. Everybody stores the height. What am I drawing? Am I not drawing the half height? Let's see, physics, half height. No, I'm using it as half height. Okay. Everything's fine. Everything is fine. Okay. So, when the player character is riding a yo-yo, height should probably be a lot less. I mean, I could just, I don't know. I don't really want to make an interface just to tweak this right now, so I'm not going to do that. That's too short. Say 3/8 maybe. Too tall? 3, 1. This is what bad programmers do. I'm being a bad programmer. Sometimes that's right, you know. Sometimes that's the right thing to do. Just be a bad programmer. Okay, so the height is 0.3, let's say, just 0.3 even. I think it's actually exactly what it is. Half length, way too long. Radius too big. Let's say radius 0.08 or something like that, and half length 0.1 maybe? Something like that. No, okay, definitely wider than that, and okay, so larger radius. Okay, we're gonna be pretty close to each other then. Could have a smaller half length. But the radius is correct. I don't know why am I drawing this pink cylinder? Let's stop drawing this pink cylinder. What is that? Let's see. There, it's taking a second. Oh, here we go. Okay, per frame character update. I'm just drawing a cylinder in the character update. Okay, that makes sense. That makes sense. Okay, so looking at how this matches the player model, it's got a little bit of a bumper in front, and it's a little bit forgiving on the corners here. I'm not exactly sure how this is going to feel, but I like the math. I like the math for solving these kinds of problems, right? Because one thing you get out of this kind of collider, maybe I'll draw, let's see. Just to highlight this point, take the front one, so the front part of the collider I highlighted in magenta here. So it's one cylinder, so I got a front cylinder, a back cylinder, and then a box connecting them. I like the way this math works out for resolving collisions because you get a lot of cool information out of a collision just from using this kind of collider, right? Whenever you collide with the front part of this collider, it tells you kind of radially where it was hit, right? If you just have a box, the box has a flat front. It's a little bit harder to determine where along the front side it was hit, right? But if you have this big bumper out front, it's just like getting it's collecting some information about the direction of where the hit took place, right? So that's why I'm probably moving forward with using this, though I may want to take some off the half length just a little bit. I don't know. Let's see, just a tiny bit. So the half length. One thing is the half length can't be less than half the radius, which is a weird thing to remember, but math breaks if you do that. Okay. See, this looks about right to me. It's basically two cylinders, but like with better edge detection or side detection, right? You get a side collider for almost free. It's like it's actually really good. So this looks about right to me. Okay. Let's see. Go back to drawing that as blue. I do want to change the line thickness, though. I don't think it's quite visible enough. Say 3, maybe. Line width. right? Okay. So that's pretty visible. Can definitely, I don't know. If you don't know what it is, you might not know what the heck you're looking at, but I think it's a good collider. Should be pretty solid, and it's a little bit forgiving too, I think. Okay. So now I just need to write the solver for this new collider type. So, physics collision, right here. Okay. I'm also going to need to add more information to the solver. So right now it only tells you how much of an overlap in the direction of the hit. I'll probably want to add more than that, but for now I will just make this next procedure do the same exact thing. So this is called, we're going to say solve collision pillbox, and we're going to start the cylinder. And I'll just copy this stuff and bring it down. Okay. Let's make all this space here. So this is where the new solver is going to go. Let's see. I'm not going to worry about check height right now. That's not important. Okay. Let's see. Basically, you have you're solving with two separate cylinders, as well as just sort of the sides of the box. Not the, you don't really care about the front of the box. So probably don't need to, yeah. So I need to sort of partly write the cylinder collisions here. So if front cylinder is going to be, oh right, this is the cylinder's pillbox. Position A, velocity A, cylinder B, so on. Okay. So pillbox A. Well, first we need to get the position of the front cylinder. So front cylinder pillbox, front cylinder position is going to be position A plus, we do not have the right, so I also need to pass in directions here. So let's see, we're going to say forward direction A is a vector 3, and right direction A is also vector 3. Is it though? Velocity, position B, vector 3? I think we'll say they're vector 2s. Because this game, though it is 3D, it takes place kind of on a 2D plane. And that simplifies things quite a lot. So we're going to take position A, and we're going to add the forward direction times the pillbox A dot half length, and then the front and then the back cylinder. Position is the same thing, but minus the forward direction. Okay. So now I have the two positions, the positions of the two cylinders. I can sort of treat them as if they were their own cylinder colliders in a way. So the front cylinder is, I think we're going toward, the collision normals point toward, so there's like an A thing and a B thing, A entity, B entity. I think they point toward the B entity. So it would be position B. Wait, are we also the normals? So if I'm using, shoot, I forget what this algorithm is called, but I think what I should be doing here is getting what the collision normal would be if it were to make contact right now and then get the overlap based on that collision normal. Though that is significantly more complicated than not doing it that way for this specific shape. Yeah. So what should I do? Let me think about it for a second here. Oh, maybe I can solve it with paint. Maybe let's see, don't save that. Maybe more solvable this way than I thought originally. So, okay. I have, let's say, a cylinder, and I have one of these things that is. This is before the collision happens. We have a pillbox collider and a cylinder collider. And so the collision normal would be probably something like this. And then let's say they collide after their velocity. Their velocity is something like this. Right. So maybe they're overlapping kind of like this. I shouldn't draw that. Hold on. Just like this. Okay. Let me draw their velocities. And so again, the collision normal is just based on their current positions. It would be this. So if I redraw them after them having moved here, and say now they're overlapping like this after moving forward a single step. Then the collision normal still works out, luckily, but it wouldn't necessarily do that, right? I'm gonna redraw it again to make that more clear, because this is complicated here. Okay. So again, velocity this, let's say this direction, and then this guy's velocity like this direction. The collision normal this time is going to be more like pointed sort of away from the top cylinder of this bottom guy. So if I redraw this after they've moved, so this guy moved along the blue velocity, and this guy moved along the red velocity line, and we have the same collision normal. It's a bit awkward, because now I have to figure out how to push this circle outside of this amoeba, basically, along this vector, which is much harder than being like, okay, what's the collision normal now? Well, it's this direction. We can push out by this much, right? That's a much easier problem to solve. So maybe I just use the collision normal from after the collision. Let's say we allow them to move. So I don't give a damn about this normal here. Allow them to move into place. And I just say, okay, now let's get the collision normal, and then move along the collision normal to solve the problem. I think that's probably what I'm going to do here. Because it is simpler. Much simpler that way. Okay. So we're going to go ahead and move their positions forward a single step. Are we using... yeah, this is using delta. This should be using... Ooh. Okay. I'm going to pretend this isn't a problem and make it a to-do, because this is actually a serious problem. Since I have a fixed physics time step, I probably should not be using this variable delta time in here. It's not good. So let's to-do that. Probably. Or figure out how to stop using it, or should I keep using it? Alright, so the first collider, position A, let's see, future position A is just going to be position A plus velocity A. Actually, let's say position A dot xy, because we're moving in 2 dimensions here, plus velocity A times delta time. And then future position B is going to be position B plus velocity B times delta time, right? And then we have multiple positions to work out here with the pillbox shape. So just to go back to it, pillbox shape has kind of like a line segment and running through the middle of it with 2 points of importance, because there are 2 circles centered at those points, right? All right. So we're going to take future position A, which is the pillbox guy, and get his front and back. So just say front position A, maybe. It's fine. Front position B is also back position A. Okay. This is future position A. Future position A. Okay. So yeah, now that I have those 2 positions, that essentially gives me a line segment and centers of 2 cylinders, right? So I try to figure out first if the other guy, let's see, is in the right position at all to even be colliding with the front cylinder or back cylinder. Which is to say, so we get diff. It's going to be front position A minus future position B. And I just need to know if that's positive, basically, with if the dot product of that with the forward direction is positive. Okay, so I just need to know if the dot product here is positive. If you don't know how this works, I think this is maybe the most commonly used trick in video game math. So if you don't know this, you should learn it. Basically, if you have 2 arrows pointing in 2 different directions, you want to know if the angle between them is less than 90 degrees. The math to do that. So say these are 2-dimensional vectors. I mean, if you don't know vectors, maybe you have to learn that a little bit, but we have a coordinate plane here, and we go over 1 and up 2, right? Over 1 and up 2. Then you can make a vector out of that, and that vector looks like 1, 2, right? And then if I have another vector, I say I go over 3 and up 0. That vector would look something like this, and that would be represented like this. You just take a 3 and a 0, you smash them together in a list. I'm not writing these in a good place. So again, 1, 2, and then 3, 0 are 2 vectors. It's literally just 2 numbers in a list, denoting that you're going over over 1 and then up 2. That's what 1, 2 means here. You're going over 3 and up 0. That's what 3, 0 means. If you just take these two vectors, you call them A and B. You say A dot B, which is the same as 1 times 3 plus 2 times 0. So you're just multiplying down and then adding across, right? If that is greater than 0, if that number is greater than 0, then the angle between them is less than or equal to, it's less than 90 degrees, right? So if you're asking, like, is something kind of in front of me? Is something not behind me, right? If something's behind you, the dot product here is going to be negative. If something is to the left or right of you, it's going to be very close to 0. And if it's in front of you, it's going to be very close to 1, right? So dot product, very useful thing, very cheap math. Maybe the number one thing, number one trick, whatever, math trick they wish you didn't know that you should know. Okay, so I take the front diff, so we'll just call it theta. Theta, or cosine theta is equal to dot of front diff with the, let's see, pillbox forward direction, A. Right? And yeah. So if cosine theta is greater than 0, going back to the diagram, new diagram, don't say. If I have like a circle here and a box here and a circle here, and then I have a circle here, I'm asking from this point right here, I know my forward direction is this way, and I know my right direction is this way, right? I'm asking from this point, I'm going to draw a vector, right? I'm asking, is there less than 90 degrees between this forward vector and this vector pointing to the other guy? If so, then we should probably be trying to handle the collision with this part of the collider, because that's the thing they're closest to. Okay? So, if cosine theta is greater than 0, we're going to be handling the collision with this part of the collider. That's basically it. And then we're going to say return and stuff. Okay. So back diff, it's the same thing but on the back side. You might think you could just take the negative, the front diff, but actually it's not quite the same because the front position is different than the back position, so you'll often get very, very different results. So you have to get this dot product as well. And I'll say, is this positive when we take the negative forward direction, which is the backward direction? And then if that's true, then again, if it's over here, we want to deal with it with this part of the collider. Right? If it's over here, or here, or here, right? So the dot product will tell us that. And return stuff here. Okay. And then, if neither of those things are true, then it must be either essentially the other guy that we might collide with is either over here or it's over here, right? It can't be anywhere else. It has to be on the sides, basically. And so that's what makes this collider a lot simpler than a basic box. Is you rule out the top, the front, and the back. the front and back Pokeballs here. You roll those out, and then once you know it's on one of the sides, the only you know that the hit normal is just going to be the right direction or the left direction, right? And the correction that you have to do. So say there's a guy overlapping right here. We know that hit normal is the direction of hit normal is, how do I put this? Ideally it's the direction that you push things away from each other that is along their smallest overlap. So like it's the direction of the smallest distance you have to push them away from each other, right? And so if this guy is colliding with the side, I know the hit normal is this direction because it's just the side of a box. You're colliding with the side of a box, right? And the overlap is right here. Or more exactly, it's just this, which is essentially the half width here, plus the radius is how far away you should be if you're not colliding with me. But if you are, then the distance, this distance from the line segment minus that distance will be less than 0, and it'll be exactly this number, right? Less than 0. This length from here to here. Okay. So if neither of these things is true, I'm going to ask what the closest point on that line segment is to the other guy, right? So for that, I'm going to take a look at a library method that I have for myself here. Closest point on line segment. And I guess I need a vector 2 version, so I'll go ahead and do that. Should be able to just make this a polymorphic procedure here. Yeah, that'll work fine. Okay. You know what? You could do the same exact thing with this one. Should just do that. So it should be vector types really. Oh, shoot. So vector types. Vector 4. I mean, yeah. Sure. So we'll just say it's a vector type situation. So T interface RIST vector types. Yeah. Okay. That should work fine. the vector types here. Okay. Best viewers, yeah, cool. Spam is fun. Everybody loves spam. Alright. So the closest point on the centerline segment just rewording it. Closest point on line segment. Let's say centerline closest point. Centerline closest point is a good name for it. The point is the other guy's position, so feature position B. And then the line segment is just the two cylinder positions, right? So front position A and back position A. Yeah. So got the closest point on that line segment. I'll use this for the normal because probably if there's like if it's slightly off, you know, I don't want it to be like, I don't want the normal to be super wrong. Okay, so, and then just get the, let's say, square distance here. So, or the distance along this vector. Yeah, I need to get the normal anyway, so I'm going to be like that. And then I just need to get the distance along that. Oh, this is obviously this. So, just the size of this. Great. Okay. So, all right, doing some math. All right, so we have the hit normal if it's on the side, and the we have the distance that they're at, and so the overlap is just going to be the negative of, let's see, vision direction, so we're doing normal, as well as let's see, the this is actually I do need to correct. The normal does have to be the rightward direction. That means it could be slightly off, which could actually get much worse. You know, this is actually much simpler than I'm making it, I think. I just need to get the difference from... Well, is it? Yeah. Okay, this is simpler than I'm thinking it. So, this is just going to be the to get the distance along the hit normal, if I want the hit normal to be the left or the right vector, I just have to get the dot product of this with the right vector, right? So let's see, right direction. Okay. And if distance is greater than 0, then we know that it is happening on the right side. If it's less than 0, we know it's happening on the left side. And so that tells us what the normal, and to flip the distance to make sure it's positive. Or actually, yeah. Okay, so the normal is going to be, in this case, right direction. And then the overlap, the amount that the two colliders overlap, is just let's see, distance. Yeah, it's just negative distance minus which has it pillbox A dot radius plus cylinder B dot radius, which, if I spread it out, let's see, negative plus, so it's just these two minus the distance. Is that right? Yeah. Okay. Nice. Okay. So if it's the other direction, we just need to go. We know the normal's on the left, so we flip the right direction to get the correct normal. And then it's the same thing, except it's combined radius plus distance, because distance is negative in this case. Okay. And then I just have to deal with the cylinder collisions that I'm not returning yet. So let's see. Alright. Actually, what am I doing right now? Let me look at my calendar. Okay. Yeah. Okay. I'm on till 1 o'clock right now, so we're still going. I'm just going to be right back. I'm going to get a drink. So let's see. Oh, 2 minutes. Okay. All right. Let's get back to it. So where was I? Oh yeah, in physics, right? Physics collision. Okay. Let's see here. Alright, this is pretty simple, right? We just need to know if... why not just do this? Could just do this, maybe. Maybe. I don't know. That would be easier. So if we know that it's going to be a collision with the front cylinder, we could just pass back the result of this function and call it a day. I think I might do that. So let's say normal and overlap is going to be... Ooh, I can't really keep... You know what? I'm going to split this. There we go. So that I can read it. Alright. So we're going to make a fake cylinder. Yeah. Fake cylinder, which is going to have radius equals pillbox a.radius. And then just need to pass all the same stuff. Let's see. Okay. Awesome. And then same thing here. So we need position A, we need front position A for this, right? Front position A, and then this should be back position A. Okay. Yeah. That'll do. And now, if I go into physics, I should be able to call this instead. Solve collisions per cylinder. Assuming that cylinders, let's go ahead and just make it like a solve collision. Yeah. In the future, I'm going to want to, like, so for this pillbox shape, I need to know what the forward direction is, I need to know what the right direction is. In the future, I'm going to want to sort of pre-calculate those and have them as like little packages that they carry around with them. But I'll do that whenever I actually do like a narrow phase or broad phase, narrow phase split. So that would be taken care of in the broad phase part. Currently, there's no broad phase, so not doing that. So I'm actually going to move this all back to move this all back into the physics collision code over here. And just call it solve collision. Okay. Nice. And the collision, we just need to know, I guess, let's say entity. Or let's get the, yeah, entity and the body at the same time, maybe. Or the position. Well, yeah, that's fine. Okay. Test, I think it's called test character. Test main character. Is that? Shoot, I forgot. Let's see. Test character is what it's called. And physics, and then we want the obstacle, and then the obstacle's physics. Okay. Back to collision, and let's see. So collider A is body A collider, and same thing with B. Oops. If collider A dot shape is equal to, first is cylinder, and the other is pillbox, which is a bad name, but it's a good name because it works. And then if collider B dot shape is equal to, and again, case cylinder, case pillbox, for each of these cases, then that tells us how to, like, which solving procedure to call. In this case, let's see, collision direction overlap. Collision direction is a vector 2. And overlap is a foot. Right. And it's going to be default 0. If they're both cylinders, they're going to solve collision cylinder. Isn't that crazy? Okay. So this is collider A dot cylinder, and let's say body A dot next position, and this is body A dot velocity dot xy. And then the other collider cylinder, so collider B dot cylinder, body B dot next position, and still, yeah, should be passing velocity here. Body B dot velocity xy. Doing some real physics here. If you can't tell. Alright. Just kidding, it's just kind of okay physics. Alright, so solve collision pillbox cylinder is going to go any case where the first shape is a cylinder and the second shape is a pillbox, or the first shape is a pillbox, the second shape is a cylinder, we can use this new solver. Right? So collision overlap is equal to this, and this is going to be pillbox, collider A dot pillbox, and then body A dot next position, and then body A velocity xy. Only using the 2D velocity because all the collisions are taking place in 2 dimensions to make it simpler. And then forward direction. So I need to get the forward direction of the pillbox. So pillbox, again, this is something that should be taken care of in the broad phase physics, but I'm not doing a broad phase right now, so it's just going to hand calculate every time. So pillbox 4 is get forward direction of entity A orientation, and then I'll just keep it simple. Pillbox. You can do something cheap here, but I'm not going to do the cheap thing. I'm going to do the fast thing. All right. Since it's 2D, right? But let's just get right direction. Okay. And I'm gonna say just make sure we normalize these as 2D vectors, just in case they're wrong. I don't care how fast it runs right now, I care that it's right. Okay, so forward direction is pillbox 4. Right direction is pillbox right. And then cylinder B, we're going to have body B dot cylinder. Position B is just body B next position, using that physics stepping position. Velocity B is body B dot velocity dot xy. And we're not checking height, but that doesn't matter. Okay. Nice. You can do the same exact thing, and it's the other way around. So when A is a pillbox and B is a cylinder, just do the same thing, but flip it around. Right? Wait, did I do it the wrong way around this? Let me see. So in this case, B is a cylinder. In that case, B is okay. I did it the wrong way. I'll just finish this and then copy paste. Okay, so actually, this this goes up here, and this goes down here. Easy peasy. Okay. Nice. What else? I think that's kind of it, except that it's not going to compile. And then I have to fix that. So, extra closing brace, you say. Oh, I see it. Oops. Get forward get forward direction. It's not right at all. Alright, there we go. Making some happy little physics here. Body B dot cylinder, right? It's collider dot cylinder, right? Not dot cylinder. Collider B, body B, cylinder, collider. A dot cylinder. A dot pillbox. Wait, what? Oh yeah, okay. And then collider B dot cylinder. Okay. What else? I wanted shape cylinder. Pillbox cylinder. Let's see. Yep. It should be pillbox. Method identifier forward direction in this. So forward direction. Okay. Mismatch, blah, 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 blah. Front position A. 1 vector 3 given vector 2. Did I do that? Front position A. Okay. Z equals position B or position A dot C. Just pass the Z along here. Yet more problems. Alright, don't match any possible overloads, next position diff, collision direction. Okay, well that makes sense. They both need to be vector 2s, but one's a vector 3. Second one, so collision direction. I'm getting as a vector 3, which is not right. Wait, what? I didn't even change anything about this procedure and it's not compiling. Oh, I see. I'm using a different compiled version of it by going down a different compile time branch than I was before. Okay. INV delta time. Let's just pass that in, I guess. And that will work fine. And then solve collisions is no longer a procedure. That is true. That doesn't go on there. Okay. Oops. Solve, please. Solve. There we go. So run, it runs. Hey, nice. Okay. So, is it gonna collide though? Let's see. If I can get it to bump. I can't really tell. I don't think so, though. Yeah, it's very much overlapping. Okay. So that'll be what I figure out when I start streaming again. I'll be streaming again later today. Thank you very much for watching, anybody who is watching now or on the VOD. I appreciate you. At least this much, but possibly this much, and the fact that you can't see how much that is, don't worry about it. Okay, bye-bye.